Good morning, friends. Today I am going to teach the fuses topic. Fuse is a piece of wire which melts when the excessive current flows in the circuit. The working principle of the fuse is Joule's law, which is directly proportional to I square RT by J, which is directly proportional to I square. Here the heat is directly proportional to I square RT by J, current and resistance and time by joules. When the excessive current flows through the piece of wire, it will melts the so the circuit is opened. Insert in series with the circuit. The fuse is inserted in the series with the circuit. Fuse is a combination of CB plus relay, circuit breaker plus relay fuse. The fuse can do both works like circuit breaker and relay. Characteristics of the fuse: high conductivity, so it need high conductivity, high resistivity. High conductivity and high resistivity, that is not only simple resistivity, it's a specific resistance. So the melting property will be not very less. Low melting point, low temperature coefficient resistance should not deteriorated with the atmosphere due to the oxidation. Low cost, the positive temperature coefficient, the fuse. Next, the material used in the fuse is tin and lead, TL. The material fuse means it is the oldest form of the circuit breaker. TL means team leader. Remember this in this way: team leader alloy, tin lead for the small currents up to 10 amperes, team leader up to 10 amperes. Tin, lead, zinc, copper, we can use these metals also. For large current, silver and aluminum is used. Next, for the best fuse material, silver is perfectly suitable. Note: zinc is a good if a fuse with considerable time lag is required. That is one which does not melt very quickly with a small overload. Zinc is a good fuse material because it does not melt quickly with small overload. So zinc is very preferable. Copper or lead tin alloy, both copper or lead tin alloy is mostly used in the ordinary fuse. We use the copper and lead tin alloy. Next, types of fuses is rewirable or semi-enclosed or kit-kat fuse. In our houses we use this rewirable fuses used low fault current. So the low fault current is interrupted by the rewirable fuse or kit-kat fuse. Next, used for the domestic and lighting loads की domestic loads की वाड़ताము. Used for the less than 11 kV. In our households it will be 11 kV, less than 11 kV. So we use this rewirable or kit-kat fuse. Next, it is a cartridge fuse, HRC fuse, high rupturing capacity. It consists of ceramic body, filling material, maybe chalk or plaster of Paris or quarters, act as a quenching medium. It is a closed body of the ceramic body. It's contain filling materials, maybe chalk or plaster of Paris or quarters, act as a quenching medium, so cooling medium. So the arc is cleared when the fuse is arced. Next, liquid fuses filled with carbon tetrachloride to quench the arc. Do you know carbon tetrachloride? It is a liquid to quench the arc. When the arc is rises in the fuse, the carbon tetrachloride is used to quench the arc. Used in the high voltage greater than 66 kV. Just remember this: fuses less than 11 kV, rewirable fuse, it up to less values. Next is greater than 66 kV. Time current characteristics. We know the time current characteristics. As the time increases, current decreases. So time decreases, fault current increases here. The graphical characteristics of the fuse. Time required to blow out the fuse depends upon the magnitude of the excessive current. As the excessive current increases, the time decreases. Excessive current decreases, time increases. The vice versa. The greater the current, smaller the time taken by the fuse to blow out. So the fuse will cut off in small time. In other words, it has inverse time characteristics. So we need to inverse. As current increases, time decreases. Time decreases, current increases. Next, fusing current. Fusing current, it's a minimum current at which the fuse elements melt. So the fuse element melts at the one current that is called fuse current. So when the fuse current flows through the fuse, then it will melts. Next, it is more than the current rating of the fuse element. It is more than the current rating of the fuse element. Next, the fusing current depends upon. The fusing current is current rating of the fuse element is more than the current rating of fuse element. As a current rating is approximately 20 amps. The fusing current may be greater than the current rating of the fusing element. The fusing current depends upon the material of the fuse element, diameter of the wire, size of the and location of the terminals. Next, length. The smaller the length, greater the current. Because of the shorter fuse can easily conduct away all the heat. So smaller the length, greater the current. So fusing current will increase for the smaller length. Next, current rating of the fuse elements are maximum current the fuse can carry without melting. The current rating of the fuse. So current rating, I previously told that 20 amperes. That 20 amperes will be the fuse current. It will carry without melting, without damage, without overheating. So it is the current rating of fuse element. It is decided by the manufacturer based on the material used, depending upon the temperature rise of the contact or fuse holders. At the fuse holders, the temperature rise will decide the current rating. Fuse material, it is designed by the manufacturer. Next, surrounding of the fuse. Current rating is in RMS value. The current rating in only RMS value, effective value. So we use RMS value. Next, fusing current. I is equal to KD to the power 3 by 2. Though K is the fuse constant, depends upon the fuse material. So I square directly proportional to T to the power 3. So I square directly proportional to R cube. So diameter, I square is directly proportional to diameter cube. Next, I square is directly proportional to radius cube. So I1 by I2 whole square is equal to R1 by R2 whole cube. So number of standards of the wire increases as the radius increases, fusing current increases. So, okay na? As a radius, we use 3 standards, so radius is small. So current is small. As we use 7 standards, though radius is more, the current is more. The current is directly proportional to the diameter to the power 3 by 2 into constant. Next, fusing factor. Fusing factor is minimum fusing current by the current rating of fuse. Fusing factor is the ratio of the minimum fusing current to the current rating of the fuse. So the current rating up to is 20 amps. The minimum fuse current is up to 15 amps. So the fuse factor is equal to 15 amps by 20 amps. So the value is always greater than 1 because for the value greater than 1, fuse factor will be applied. So copper finishing factor, copper fusing factor. So based on the material we use, the fusing factor will changes. For copper, fusing factor is equal to 2. Next, perspective current, RMS value of the first loop of the fault current. Here the fault current cycle. Here the normal current, here the fault current. The fault current cycle. Here I will going to explain the fault current cycle. Next, here the x-axis and y-axis. X-axis taken as the time and y-axis taken as the current. So here the normal AC waveform. Here the fault occurs. Here the cutoff current and here the total operating time. Here up to this total operating time, the fuse will totally operated. It is a p-arcing time. Next, it's a asymmetrical current. It's current 0, arcing finish. Arc is finish. Next, perspective current may be defined as the current that would flow in the circuit under fault condition. Under the fault condition, next the current flows is known as perspective current when the fuse wire is replaced by the link of the negligible impedance. Next, cutoff current. Cutoff current is the instantaneous value. Instantaneous value is a cutoff current. Maximum value of the fault current reached before the fuse melts. Cutoff current. Here the cutoff current. Here see. Here the cutoff current. The maximum value of the fuse reached before the fuse melts. Before the fuse melts, the maximum value of the in the graph I will indicate as the maximum value. Before the fuse melts, it will the maximum value of the fault current. It is known as cutoff current. It which that the fuse, after that fuse melts. Depending upon the current rating of the fuse, the fuse will sustain the cutoff current. Based on the value of the perspective current and asymmetry of the short circuit current. Circuits protected by the fuse can be designed to withstand the maximum current equal to the cutoff value. So cutoff current is greater than the fusing current. So circuit is protected by the fuse designed to withstand maximum current equal to the cutoff value. So pre-arcing time. Pre-arcing time is the time between the fault occurred and instant where the cutoff occur. Where here the fault occur, here the cutoff. This the region between the fault occur and cutoff region is called pre-arcing time. It is a pre-arcing time. So pre-arcing time is the between the fault occurred and instantaneous the cutoff occurs. Time between the fault started and arc is initiated. Generally, pre-arcing time is generally 0.001. Please remember this. It will asked in the sub-engineering exams. Next, arcing time. Arcing time is the between end of the pre-arcing time and instant where the arc exists. Arc extinguished. So here the arc started. Here arc extinguished. So this time where the cutoff current and end of the arc. So this is called arcing time. So operating time is based on the pre-arcing time plus arcing time, total time. So the total time where the fuse is operated is known as operating time. Less than CB. Fusing operating time is less than CB. So the fuse can be effective than the CB. So fuse operation is very greater. When they asked the question like operating time of the which device is less, in these options we get fuse, circuit breaker, isolator, switches. So we need to answer the fuse. Fuse has operating time of 0.002 seconds, but CB has an operating time up to 0.05 seconds. So we need to answer the fuse. Next, breaking capacity. It is the RMS value of AC component of the maximum prospective current that fuse can deal with the rated service voltage. Breaking capacity. AC components of the maximum prospective current the fuse can deal with it. So RMS value the fuse can adjust the to operation. Advantage of the fuse over CB. Do you know that advantage? It has less operating time. It is one of the best advantage. So fuse break the circuit breaker. Fuse does not need any relay. So fuse is the advantages than the circuit breaker. Here is one of the advantage also. Fuse can break the circuit very faster than the circuit breaker. Next, here the fuse works based on the thermal energy. At first I told that H is directly proportional to I square RT by J. Continuous current rating of fuse is equal to 0.8 into continuous current capacity of the conductor forming circuit to be protected. Continuous current rating into the is equal to 0.8 into continuous current capacity of the conductor. So thank you for watching my video. Please subscribe and like and share. Please do subscribe and follow my channel.